Hi everyone! Good afternoon sir, good afternoon classmates. I am the third reporter of Group 1 and I am Miss Novia Merlimbi Teperla. At this moment, we will talk about Fourier Series. But before we proceed, let us read first our objectives of this moment. First, we will illustrate Fourier Series, find the coefficients of Fourier Series, and find the equation of the graph. Let's discuss first the history. Fourier series was invented by French mathematician named Jean-Baptiste Joseph Fourier. He was born in Auxerre, France. He was the son of a tailor and an orphan at the age of 9. He then joined the army and educated at the scientific section of the army corps. Day by day, he then admitted himself in many renowned institutions of France and other countries. Definition of terms. Fourier series is a way of representing a periodic function as a possibly infinite sum of sine and cosine functions. It is also analogous to a Taylor series, which represents functions as possibly infinite sums of monomial terms. Now, for those functions that are not periodic, the Fourier series is replaced by the Fourier transform. Did you know that sine and cosine waves can make other functions? Of course you know. Just like this. So we have here a grapher. So let's try to input some functions. Let's say sine x. So we have there. And let's say cosine x. So we have it here. Sine x and cosine x. How about if we make it sine 2x? And we make it, let's say, sine 3x. So it looks like that. How about sine 50x? Oh, and cosine x. It's very pretty graph. Now, can we use sine waves to make a square wave? Of course we can. So let's start first with sine x. So this is our square wave, yung dotted line. And then let's take sine 3x over 3. So ito yung itsura. Then let's combine them. Okay? And how about sine 5x over 5? And let's try to combine sine 5x over 5 to the functions kanina. So it becomes like this. So almost square na siya, no? Then, let's try to improve. Gawin natin using the 20 sine waves. We get this one. Almost na talaga. And what more kapag 100 sine waves? So, magiging almost square function or square wave na talaga siya. And if we could add infinite sine waves in that pattern, we would have a square wave. So we can say that a square wave is equal to sine x plus sine 3x over 3 plus sine 5x over 5 and so on. Now, this is the idea of a Fourier series. By adding infinite sine and or cosine waves, we can make other functions. Now, let's take a look at this video para mas ma-visualize natin ang Fourier series.
Yeah, and so the first harmonic, n equals 1, gives you this?
Yes.
Which looks nothing like it.
Nothing interesting, just boring sine wave. And I add one more. It's actually like it. I'm adding one harmonic and other one third of that harmonic radius.
So you're adding a base. What are we going to call these? Wipers?
Yeah, let's call them wipers.
Okay, so we're going to add a wiper on a wiper. And by doing that, and we graph the function.
And then follow the tip of these wipers.
Yeah.
And draw that this way to time. So I can add more wipers. Maybe it's more harmonics. And I add 15 harmonics. It's something very cool.
Oh wow, it looks like a whip.
Hindi ba it's fascinating to see? Now, how did you know that we used sine 3x over 3, sine 5x over 5, etc. That's right, because we have this formula or the Fourier series. So we have f of x equals a sub 0 plus the summation of cosine nx pi over L times a sub n, where n starts from 1 to infinity, plus the summation of sine nx pi over L times b sub n, where n starts from 1 to infinity. F of x here is our function that we want, and L is half of the period of the function. So if you want to solve the full period, so we will use 2L. And a sub 0, a sub n, and b sub n are the coefficients that you need to calculate. So we have this formula. This part here is a cosine Fourier series, and this part here is a sine Fourier series. Now, let's try to look at cosine Fourier series. Cosine Fourier series uses sigma notation, just like sine Fourier series. This means to sum up the series of values starting at n equals 1. So it means a sub 1 cosine 1 x pi over L. A sub 2 naman is cosine 2x pi over L. A sub 3 naman is cosine 3x pi over L, and so on. So, the same lang dito kay sine Fourier series. So, b sub 1 sine 1x pi over L, b sub 2 sine 2x pi over L, b sub 3 sine 3x pi over L, and so on. Now, before we can have the equation, let's find first the values of a sub 0, a sub n, and b sub n. And how do we get that? We have this formula. So, a sub 0 equals 1 over 2L times the integral of f of x dx from negative L to L. So, this time, 2L siya, it means yung one whole period. And a sub n equals 1 over L times the integral of f of x cosine n x pi over L dx from negative L to L. So, this means yung half period lang muna. And the same with b sub n equals 1 over L times the integral of f of x sine nx pi over L dx from negative L to L. Now, what does this mean? It is an integral, but in practice, it just means to find the net area of f of x sine nx pi over L between negative L and L. So, the same dito. Net area ni f of x cosine nx pi over L dx from negative L to L. So, this is what we need to do. Let's take our target function, multiply it by sine or cosine, and integrate or find the area. And do that for n equals 0, n equals 1, and so on. After we calculate all the coefficients, we put them into the series formula na sinabi ko kanina, or the Fourier series. Let's try to solve the function of square wave. Saan ba galing yung equation kanina? So, we have here the square wave. And L is equal to pi. So, this one, it is equal to pi. The period is 2 pi. So, it means, kung 2 pi na siya, it means 2L rin. The square wave is from negative h to h. Yan. Now, let's find the values first of a sub 0, a sub n, and b sub n, or find the values of the coefficients. So again, ito yung mga coefficients that we need to solve first para ma-substitute natin later sa series. Okay? So, a sub 0 is a net area between negative L and L. So, yung negative L and L dito. Then divided by 2L. And then let us look at the sketch. So as you can see, the net area of the square wave is 0. Okay? So from negative L to L, it is 0. Okay? If we add it, it becomes 0. So our A sub 0 is equal to 0. So let's try to solve A sub n, or our coefficient here. So A sub n is equal to this formula given kanina. We know that n is equal to 1 and L is equal to pi. So we have this. Substitute lang natin. So we have A sub 1 equals 1 over pi times the integral of f of x cosine 1x pi over pi dx from negative pi to pi, which simplifies to this. Simplify natin. So 1x naging x na lang, and ito naging 1. So it becomes that. And now, because we have a square wave, changes abruptly at x equal to 0, we need to break the calculation into negative pi to 0. So from negative pi to 0, we know f of x is simply equal to negative h. So yan, negative h. Labas natin si negative h, so this become like that. And ito. So we have negative 0, or so we have negative pi to 0, and it is simply negative h. And yung kabila naman is positive h. Ito, positive h. And as you can see, the net area of cosine x from negative pi to 0 is just equal to 0. And from 0 to pi, equal to 0 pa rin. Which means, our A sub 1 is just equal to 0. And yung kanina, A sub 0 natin is equal to 0. And if we will try to continue it, continue lang natin, ganun. And so on. 0 pa rin ang result. Which means, A sub n is equal to 0. So we have our two coefficients, A sub n, which is equal to 0, A sub 0 is equal to 0. So B sub n na lang ating isosolve. So, now let's try to solve for B sub n. Okay, we have this formula given kanina, and we know that n is equal to 1 and L is equal to pi. So, substitute lang natin. Then, let's simplify. And we have here, our f of x is equal to negative h. Labas natin sa negative h. So, we have negative h over pi times the integral of sine x dx from negative pi to 0. So, if we try to look at our graph, saan ba galing si negative 2? Okay, so, dyan. Okay, so we will try to integrate. The integral of sine x dx is just equal to negative cosine x. So, we try to calculate the definite integral. So, negative cosine 0 minus negative cosine negative pi is equal to negative 1 minus 1 equals negative 2. Which means, we have, substitute natin, we have negative h over pi times negative 2. And dito tayo sa kabila. From 0 to pi. So, we have negative cosine pi minus negative cosine 0 equals negative 1 minus negative 1 is equal to positive 2. Which means we have negative h over pi times positive 2. Now, let's combine both sides. So, we have b sub 1 equals negative h times negative 2 over pi plus negative h times 2 over pi. Simplify natin. And we got b sub 1 equals 4h over pi. So, we have now our first coefficient, b sub 1. Now, let's try b sub 2. Okay? Saan ito galing? Si negative h over pi times the integral of sine x 2x dx. Dito yan siya. Okay, dito. So, we will substitute here our function. So, from sine x, gamitin sine 2x, sine 3x, and so on. So, we have negative h over pi times the integral of sine 2x dx from negative pi to 0. And, if we try to sketch it, or just analyze it. So we have here sine 2x. So ito yung sine 2x from negative pi to 0. So ito yung sine 2x from negative pi to 0. What can you observe? Yes, the net area is 0. How about, so we have now b sub 2 equals 0. How about for b sub 3? Same lang kanina. Okay, ito na yung b sub 3. What have you observed? Itong two areas na ito is magiging 0. But the third one is important. So it is like b sub 1 integral, but the only 1/3 of the area. So let's try to look at yung sa right hand side. So we have 0 to pi. Ito rin, magiging cancel din ng isa. And may isa na naiwan. And we then conclude that b sub 3 is just b sub 1 over 3 or 1/3 ng b sub 1. So we have 4h over 3 pi. So the pattern continues. So ito, sine 4x na, di ba? So 0 na siya. Then we can conclude na kapag ang n is even, then the areas cancel for a result of 0. Pero kapag odd naman, may iwan talagang isa. So, it will result of 1 over n. So we can say b sub n equals 4h over n pi when n is odd but 0 otherwise. So let's recall to list. A sub 0 is just equal to 0. A sub n is equal to 0. B sub n is equal to 4h over n pi when n is odd. And b sub n is equal to 0 when n is even. Now, let's substitute all of the coefficients sa ating equation. So, we have a sub 0 is equal to 0. A sub n is equal to 0 times cosine yung function na to. So, it becomes 0 pa rin. Plus our b sub n. What is our b sub n? So, if n is odd, ito and when n is even is 0. So, we have 0 plus 0 plus 4h over pi times sine x plus sine 3x over 3 plus sine 5x over 5. So, this is 1. And 2, ang 2 hindi ko na sinulat kasi 0 pa rin. Then 3, ito. 4, 0, 5, sine 5x over 5 plus yung 6, 0, and so on. So, simplify natin. So, we have 4h over pi times sine x plus sine 3x over 3 plus sine 5x over 5 and so on. Diba? It's very easy and it's very interesting to learn. Now, here are a few well-known ones. So, ito yung mga well-known na mga waves. So, we have a square wave, yung sinolve natin kanina. Ito yung series niya, and ito i-input natin sa Fourier Series grapher. Sawtooth, ito, pulse, triangle, and so on. So, we can graph the Fourier Series. So, I found this website where we can graph. So, let's try to graph it. Let's try this sawtooth. So, ano itsura ng sawtooth? Have here the grapher. So, ang sawtooth daw is sine times n times x over n. Over n. So, yan ang itsura ng sawtooth. But, let's try to make it from n is equal to 1 to 10. Yan ang itsura. How about 50? How about 100? So, yan ang itsura ng sawtooth. Let's try this. Let's try another one. How about pulse? So, times 0.01. Saan ako galing ng mga values dun sa table na pinakita ko? So, ito yung itsura ng pulse. So, if 10 lang yan, so, yan lang yung itsura. Kung 10. Yan ang itsura kung 10. Kung 20. Kung 50. Hanggang 50 and hanggang 100. Yan ang itsura ng pulse. So, it's very interesting. So, ang triangle, kayo na lang ang mag-graph ng triangle. So, I'll give you the link. Now, let's try to look at this video on how did he use Fourier formula to make this really, shall I say, abstract drawing. Okay, so take a look at this.
He actually can do it. He can model this using nothing but circles in the Fourier series, which is completely impressive. Check this out. The first thing that he has to do in order to draw this image is to extract the x and y positions that he would need to make functions for in order to make this thing work. He then needs to create a Fourier series for each one of those functions so that he can add them together. And as you can see, these first few were not winners. I mean, like, no stretch of the imagination could make your brain think this looks like the side profile of a human head. Everything's a bit derpy. But as he starts to refine it and he adds more and more waves to the functions, things start to hone in and it starts to look really good. At about 40 circles in this whole function, things start to look really good, and your brain would totally think that you're looking at a drawn image instead of a mathematically drawn function. If you look closer at just one of these arms, you would think that it's chaos, but it's not. It's complete order backed up by a mathematical function. In fact, this is why I love math. It's the language that describes the entire physical world. We can approximate anything as long as you have enough terms. This is the beauty of the Fourier series. You take simple things you understand, like oscillators, sine waves, circles, and you can add them together to do something much more complex. And if you think about it, that's all of science and technology. You take these simple things and you build upon them, and you can make a complex system that can do incredible things.
All right. Now, can we do the same like that? Can we do Fourier series? Of course we can. We should have more patience in doing it, and we should have passion in doing it. What are the applications in our real life that Fourier series has been applied? So we have signal processing, image processing, heat distribution mapping, wave simplification, light simplification, interference, diffraction, radiation measurements, and so on. Remember, great things are done by a series of small things brought together. By Vincent van Gogh. Thank you very much for listening. I hope you learned. Thank you very much.